Welcome to This Explainer. Okay, if you manage servers, or honestly, even if you're just dipping your toes into Linux, you know that absolute stomach-dropping panic of a sudden, unexplained system crash. Today, we're going to take that sheer panic of a crashing Linux server and totally transform it into a highly manageable, step-by-step diagnostic process. I mean, we've all been there, right? Picture this dreaded scenario. It's 2 a.m. Out of nowhere, your normally rock-solid Linux server just becomes suddenly sluggish. Your website is completely stuck, just loading endlessly. You try an SSH login to see what's going on, but nope, it completely times out. And man, if you're actually near the physical machine, the cooling fans are screaming like jet engines taking off. You finally manage to check, and boom, there it is, CPU usage sitting at 100%. Okay, let's dive right into this and figure out who or what just ate all your CPU. So here's our roadmap for today. We'll quickly cover what is a process, causes of CPU overload, how to catch culprits, stopping rogue processes safely, system load average explained, and finally, a real-world server rescue. Let's get to it. Section 1. What exactly is a process? Well, to fix a server, we first really have to understand what makes it tick, right? We need to establish the absolute fundamental building blocks of a Linux system. See, in the Linux world, literally everything currently executing is called a process. When you open up a browser, that's a process. When you start a web server, process. Even just logging in via SSH generates a process. But what's the crucial difference between a program and a process? It's actually pretty simple. A program is just a sleeping file. Actually, think of it more like a blueprint, resting quietly on your hard disk, doing nothing. But once it gets executed and woken up at a CPU, it becomes a living, breathing, active entity. And that active entity is the process. Think of the Linux kernel as like the ultimate general manager of a highly organized company. For every single living process, this manager assigns very specific resources. It gives it a PID, or process ID, which is basically like an employee badge number. It allocates memory to work in, actual CPU time to get the job done, security permissions, and file handles to interact with data. Basically, the kernel decides exactly who gets to use the CPU and when. Moving on to Section 2, causes of CPU overload. Look, when your CPU usage hits 100%, it essentially means the processor is running constantly with absolutely no time to rest. There's some process out there just wildly consuming computing resources. So, what actually causes this? Well, here are the 4 most common culprits. First up, infinite loops. If a programmer accidentally writes a loop that literally never ends, like a while true statement in Python that just calculates forever, your CPU is going to be drained dry. Second, massive requests. Say your web server suddenly gets hit by a DDoS attack, some rogue web crawler, or bad API abuse, that sudden flood of traffic will max out the CPU instantly. Third is insufficient memory. When your RAM completely runs out, Linux starts using swap space on the hard drive. Swapping data back and forth from a slow disk takes massive CPU overhead, slowing the whole machine to an absolute crawl. And fourth, the scary one, malicious programs. Hackers love to sneak inside and secretly plant crypto miners that just quietly eat up all your processing power. All right, Section 3, how to catch culprits. Now that we actually know what we're looking for, we need some rapid-fire forensic tools to interrogate the system and find out exactly who is misbehaving. Your absolute first line of defense is the top command. You can think of top as the time-tested, classic dashboard for your server's health. You just type top into your terminal, and boom, it immediately shows you overall CPU usage, memory usage, and a dynamic, live list of which specific process is currently eating the most CPU. It's totally the gold standard for a quick overview. But, if you want something a bit more modern, you use HTOP. This is like an evolved, upgraded alternative to your standard top. It's visually colorful, it's way more intuitive, and honestly, it makes monitoring multiple CPU cores an absolute breeze. You can clearly see individual core performance visually rather than just staring at giant walls of text. Sometimes, though, you don't really want to sit there watching a dynamic dashboard, you just want an immediate answer right now, and that is where the PS command comes in. By typing ps-aux sort-CPU head, you're essentially using a laser pointer. This specific command instantly sorts all running processes by CPU usage and lists the heaviest hitters right at the top of your screen in one single snapshot. And finally, we complete our forensic toolkit with PitStat.
If you've identified a suspicious process and really want to watch it closely, running PidStat1 gives you real-time, second-by-second updates on the CPU usage changes for that specific active process. It's absolutely perfect for detailed, focused observation.
Let's jump into Section 4, Stopping Rogue Processes Safely. All right, so you found the culprit. Great. But now we really need to cover the crucial rules of engagement for safely neutralizing that threat without causing, even more damage. To stop a process, you use the kill command followed by the process ID. Now, a standard kill PID is a normal termination. Linux basically sends a polite signal notifying the process that it should stop, which allows it time to save its data and close files gracefully. But if a process is totally frozen and just won't listen, you might be really tempted to use kill -9 PID. This is forced termination. It sends a sig kill command, abruptly pulling the plug. You must be super careful here, because aggressively pulling the plug means the process shuts down instantly, deeply risking data loss and corruption. Always, always try the polite way first.
Section 5, System Load Average Explained.
Okay, now it's time for the big plot twist of our explainer, because surprisingly enough, seeing a 100% CPU isn't always a disaster. I know, crazy, right? A lot of people assume 100% CPU automatically means a broken system. But if your server is doing legitimate heavy lifting, a maxed out CPU means it's doing exactly what it should be doing. If you're running AI model training, executing complex video transcoding, running massive data analysis, or conducting deliberate stress testing, 100% CPU is totally normal. The real question you should be asking isn't just, is the CPU at 100%, but rather, is the CPU being used for the correct work?
So the truly crucial metric you want to look at here is called load average, which you can check using the uptime command. Honestly, senior Linux engineers watch this metric obsessively. Load average represents how many processes are backed up, just waiting in line for CPU time. Imagine a 4-core CPU. If the load average is exactly 4, that's perfect. 4 lanes of traffic, 4 cars moving smoothly. No problem. But if that load average hits 20 on a 4-core CPU, yeah, that is a massive CPU traffic jam. It means 16 processes are desperately waiting for their turn, and your system is severely, severely bottlenecked.
Finally, Section 6, Real-World Server Rescue.
Let's bring everything we've learned today together by applying our new knowledge right back to that initial 2 a.m. nightmare scenario we talked about at the beginning. Here is the exact sequence of a real-world server rescue. Step 1. The website crashes at 2 a.m. and the alerts just start firing off. Step 2. Our focused engineer logs in via SSH and immediately runs the top command to survey the damage. Step 3. Scanning the dashboard, they spot a bizarre process called python-miner.py, consuming 99.9% of the CPU. Not good. Step 4. The diagnosis is complete. It's not a normal traffic spike. The server was actually implanted with a hacker's crypto miner. Armed with this info, the engineer can now confidently use the kill command to terminate it, secure the server, and finally go back to sleep.
To wrap things up, I really want you to remember this core medical metaphor. In the world of Linux, every single process is like a living cell in a human body, naturally consuming system resources just to survive. 100% CPU spike, that's merely a fever. It is just a symptom pointing to an underlying condition. You can't just treat the fever, you have to find the infection. A truly great systems engineer doesn't just panic and reboot the machine the second they see CPU usage hit 100%. They use their tools to find out exactly which process is secretly burning down the server. So the next time your server fan starts screaming in the middle of the night, what will you look for first? I hope this explainer has totally empowered you to tackle server diagnostics with confidence. Keep exploring, keep monitoring, and we will see you next time as we continue to decode the fascinating mechanics of systems architecture.